There are virtually unlimited choices when it comes to choosing an electric fuel pump for your vehicle, but how do you know where to start and which pump is the right one for you? Well, hopefully I can give you some insight and knowledge before you make your next pump purchase. One of the first questions you'll need to ask is what operating pressure you'll need for your particular setup. Are you running a carburetor, or is it electronic fuel injection? Carburetors typically require between 2 and 9 psi, while current EFI systems have operating pressures anywhere from 40 to 60 psi. The pump design itself can actually dictate performance as well as cost. Some of the most common pump designs include a diaphragm, vane, G-rotor, and even screw pumps. Fuel pump manufacturers typically advertise their free flow rate in gallons per hour, or sometimes even pounds per hour. This is the amount of fuel that they can flow unrestricted and not under pressure. You'll need to consider fuel pressure and its relationship with fuel volume to select the correct pump for you. Pressure and volume are inversely proportional, meaning as the fuel pressure increases, the flow rate actually drops off. An EFI engine will require a higher capacity pump than a carbureted engine. The amount of fuel being consumed by both engines is the same, but since EFI requires higher pressures, your flow rate will decrease. Make sure that the fuel pump you select can flow an adequate amount of fuel for your engine at the required operating pressure. Holley's website provides convenient charts showing the flow rates of each of our fuel pumps at various pressure readings. Another design option that you'll have to consider is whether you plan to use an Intank or an Inline style fuel pump setup. There are pros and cons to both these setups. In-tank pumps can benefit from the cooling effect of the fuel being in the tank, but an inline pump is easier to replace and typically less expensive to purchase. There are several factors to consider when making your fuel pump selection. Engine horsepower, brake-specific fuel consumption, type of fuel you plan on using, system pressure requirements, filtration, and supply voltage are all critical to your selection. To make the proper pump selection, start by determining your vehicle's maximum horsepower. You can do this by either dyno testing the vehicle or using the manufacturer's advertised horsepower rating. Be sure and take into consideration any modifications or upgrades that you may have done to your engine. To be safe, estimate the horsepower on the high side. The second variable in the equation is brake-specific fuel consumption. This is a measurement of the amount of fuel consumed per unit of power produced. As a reference, most naturally aspirated engines running gasoline have brake-specific fuel consumption factors from 0.4 to 0.5 pounds per horsepower per hour. Nitrous combinations use slightly more fuel and develop factors around 0.5 to 0.6 pounds per horsepower per hour, while forced induction engines such as blown, supercharged, and turbo engines typically require the most fuel and have brake-specific fuel consumption factors ranging from 0.6 to 0.75 pounds per horsepower per hour. Keep in mind that the type of fuel you're using is yet another factor. If you run ethanol, plan on consuming 30 to 35% more fuel. Using methanol can increase fuel consumption by as much as 100 to even 200% more than gasoline-burning engines. Use these variables to determine the gallons per hour needed for your engine with this simple equation. To determine our gallons per hour needed, we'll need to know the maximum horsepower of your engine and the brake-specific fuel consumption factor that we determined earlier. You'll also need to know how much your fuel weighs. The 6 here represents the average weight of a gallon of pumped gasoline. If you're using alcohol, methanol, or another fuel, this number will change. Consider our engine makes 350 horsepower. We need to multiply that by 0.5, which is the brake-specific fuel consumption factor for a naturally aspirated engine. Multiply the two together, we get 175. Take that 175 and now divide it by 6, the average weight of a gallon of pump gas, and we come up with 29.166 gallons per hour repeated. So we need a fuel pump that's capable of supplying at least 29 gallons per hour for our particular engine. There are definitely plenty of other factors that you'll have to take into consideration when you're selecting a fuel pump for your system. Some fuel pumps are capable of regulating the fuel pressure. Typically, these are lower pressure situations. Holley's red pump is a good example. Higher pressure systems likely will need an external fuel pressure regulator to maintain the operating pressure suitable for your setup. To return or not to return? It's a very good question. Should I run a return line, or can I get by with running a non-return style system? Most EFI systems can be deadheaded, but it's recommended that you use a return style system for the best performance. A return style system allows the pump to constantly circulate fuel, which helps eliminate air pockets as well as cools the pump as the fuel flows through it. Remember to run the dip tube for the returning fuel, below the fuel line to help prevent aeration of your fuel in the tank. Deadheading the fuel system can cause pressure oscillation and excessive heat to build up at the pump due to the forces acting against it as it's trying to deliver the fuel. Although it's not usually required, carbureted setups can actually benefit from a return style system, which can help cool the fuel and prevent vapor lock as well as fuel percolation. Let's not forget about filtration. This is one of the most important components in your fuel system and can also affect the pump performance. A 100 micron high flow pre-filter is pretty much the industry standard. Some examples of a pre-filter: Holley's Hydromat, or a filter sock like what's used in an OEM Intank unit. Or you could have an external canister style or even a screw-on element, some of which are serviceable and some are not. Post filters vary, but typically you can use a 10 micron post filter for most EFI setups and a 40 micron filter for carbureted engines. Your filter should be able to flow 50 to 100% more fuel than the free flow output of the pump you're using. This is to compensate for the flow loss as the filter traps debris in your fuel system, reducing the flow. Remember that as the system pressure decreases, so does the boiling point of your fuel. This drop in boiling point increases the possibility for vapor lock to occur. Fuel line size is another factor that can affect pump output efficiency. The best fuel pump in the world is worthless if the fuel delivery is inadequate. The inside diameter and the total length of fuel line used both affect how your fuel pump can deliver the fuel. Fuel line inside diameter should be matched to the pump outlet inside diameter. The horsepower guidelines below are a good starting point for selecting your fuel line size. Dash 6 AN is good up to about 550 horsepower. Dash 8 AN used for over 550 horsepower, and use Dash 10 for over 1,000 horsepower. An easy way to associate the AN line size to the actual inside diameter of fuel hose is to remember that for every dash, it's equal to 1/16 of an inch. So if you have a Dash 6 AN line, it's 6/16 of an inch or reduced down to 3/8, and so on. The last factor to be considered is the voltage supplied at your fuel pump terminals. Higher voltage at the pump translates into increased motor torque and an increased flow volume at any given pressure. Voltage to an electric motor is like fuel pressure to an injector. More pressure in equals more volume out. Using a 16-volt race battery or eliminating a functioning alternator from your electrical system can affect the performance of your electric fuel pump. There are plenty of other factors that are less critical but can still reduce your fuel system's performance. Things like how many fittings and the design of the fittings themselves, like if you're using a tube or a tight radius fitting. Also, close proximity to high heat sources and vibration can have a negative effect. We also recommend that you install a visual aid, such as mechanical fuel pressure gauges or a fuel pressure transducer, to help you monitor your fuel pressure. It's especially handy to have when you're trying to diagnose a fuel delivery or fuel starvation problem. Follow the recommendations and take some time to plan out your fuel system carefully. Match the fuel system components to your particular engine build and future expectations. Remember, the biggest or most expensive pump is not always the best pump for your setup. Using quality components and arming yourself with some knowledge will pay off with better engine performance and longevity. Thanks for watching. To find out more about any of our high-quality fuel pumps, fuel pressure regulators, and fuel filters, visit our website at holley.com.